On this video, I'm going to perform the hypothesis test that I've put in my analysis plan. Before I do that, though, I need to complete my analysis plan. So I need to come in, I need to go look at my data and I need to get my sample sizes. So the first one for N1 is the houses with 3 bedrooms. Someone go back here to this hypothesis prep stuff I did to just come up with this. I just did a pivot table on the number of bedrooms in the listing, the house that sold and how many bathrooms there were. And because I'm actually trying to get a sample size on the number of bedrooms, right? Houses with 3 bedrooms or houses with less than 3 bedrooms. I don't really need this crazy giant table with all these baths. So I'm going to just remove baths from the pivot table. So now I have this count that's a lot easier to deal with. And I can see here that the number of records with a house that has 3 bedrooms. So this is, this is the number of bedrooms. So I can just go ahead and grab this number and we're going to put that in the analysis plan. Oops, where'd it go? All right, formatting's a little weird, but that's okay. I'm not going to worry about it right now. Maybe. Oh, what's it doing? Okay, there we go. All right, so then for N2, we're going to be looking at group 2, this number of records in group 2. Now, I don't care about the average square footage when I'm doing this. All I'm going to care about is that the number of houses is, I want to know how many records are houses that have less than 3 bedrooms. Okay, so coming back over here, I can actually filter this down by choosing the label filters. So these are the labels, right, of how many bedrooms there are. So I'm going to unselect everything. And I'm going to only select 1 and 2 because those are the only ones that are less than 3. If I had something more complicated, I could actually use a label filter to help us. And we'll probably see that later. But so we put this in and we see that this amount of bedrooms is 1199. So I'm going to copy that over to our analysis plan, which is the other number I needed to get. Oops. And it's bold because the pivot table had bolded it because it was a grand total. So, all right. So for the test statistic that goes here, I'm going to check back in our chapter 5 notes because I want to make sure I get it right. And looking back at our chapter 5 notes, I remember that we're going to use, I'm going to copy that into here so I don't have to retype that. So I have this formula, and just for formatting purposes, I'm going to stick that in the middle. All right. So this is I'm going to get the sample means from each group. And I know that when I subtract mean 1 from mean 2 from the null, the expected value up here will be a 0. Right, so then everything else I need to get from the data. The S1 squared is going to be my sample variance. And I'm going to be able to get that using the descriptive statistics in Excel. Okay. Okay, so now the next thing I need to do is actually create my 2 groups to run this analysis. So I'm going to switch back over to Excel. I'm going to add another sheet here, and I'm going to rename this sheet group 1. And then here I'm going to say that this is going to be looking at my hypothesis. So let's go back so we're all on the same page. Is houses with 3 bedrooms. Okay, so to do that, I'm going to go look at this data, and I'm going to go to bedrooms, and I added, by going to the data tab, I added the filters, right? So I can filter. So I'm going to unclick select all, and then I'm just going to pick 3. And now I just have houses with 3 bedrooms. So I'm going to get all this data. I'm going to go from the top left corner And I'm going to scroll down. This is a big data set, so I know it's already what, like close to 5,000 records here. So I'm going to shift click here and right click copy, and then come over to my group one, and I'm going to right click values. So now I have the data of the bedrooms, subset it to where there's only 3 bedrooms. Okay, now I'm going to add group 2. Okay, so group 2 data. And for that, I'm going to come back over here to houses near colleges. I'm going to clear up here in the data ribbon. I'm going to clear all the filters. That's a quick way to do it. Then I'm going to go with houses that have less than 3 bedrooms. So again, I'm going to just click 1 and 2. And now it has subsetted for me. And I'm going to copy all of these records over with just their values because I don't want to deal with the filtering, which will mess up some things in Excel. Some things will be fine, some things won't, and you won't know the difference, and that can mess you up. Okay, so I'm coming over here to group 2. I'm going to right click and I'm pasting the values, right? We're all familiar now, hopefully, that that's the way to do it. Okay, so now I have my 2 groups of data. I definitely need to go back in and describe what this is. This is the group 1 data, and here I define what this subset is. Okay, so I'm not doing it. You need to do that though. You need to make sure, you know, your worksheets have clear instructions to anyone who looks at them as to what they are. Okay, so we're going to want to put the same thing, information on what the group 2 data is over here in group 2. Obviously, this is group 2. Right. All right, so now let's add another sheet, and we're going to call this one the hypothesis test. So some of you guys have like where you're splitting up your data based on the average. So obviously what you would have to do for that is back here in your hypothesis prep, you have the average somewhere, and then you go to your data and you're going to say, you're going to use like a, when you filter your data, you would go up here to the filtering tab. And let's say you were looking at sale amount greater than the average or something. You want to go in and you can, in the filters, come down and you can say greater than or less than or greater than or equal to or equals to. So you can use this to create a type of just an inequality. So you want when the sale amount is, and notice at this point right here could be actually a pop out. I believe that will let me. Yeah. Oh, it's showing me all of them. So I don't know. Maybe it won't let me. Let me try it. No, it's not going to let me. You actually have to type in the number. So you have to have it. So let's do it the other way. We would go here. Let's say we want the sale amount and the average. We want it greater than the average. I'm going to copy this number. I'm going to see if this works. Go in here and go, okay, I want the sale amount. I want to filter to where it's greater than. And let's see if I can put that number in here now. Yeah. So you can do it that way. And then you just say, okay. And now you automatically filtered, and then you copy that into like group 1 or group 2. Okay. So that's how you would do it. And I'm going to clear this, clear all my filters here. This needs to be my original data. So this is the original data. Let me make sure you state that. I can't type. Okay. So now that I have my group 1 and my group 2 data, I'm going to go in and I'm going to start setting up the hypothesis test. So, so you can put hypothesis test. And right here, I would state what the question is, just copy it from the analysis plan. So let's go ahead and do that. Oops, I skipped, I was in the wrong place. There we go. So I'm going to copy this question in here. So let's copy that into Excel. I'm going to put that here. All right. And it threw in my comment. Okay. Get rid of that. Okay. let's go ahead and go over to the analysis plan and actually put in these definitions. So it's really clear what we're doing here. Let's put in group 1. And I'm going to get rid of that A. We don't need the A. And let's go in and get group 2. I think it's going to just keeps wanting to do this. Okay. The other thing that we would want to do, I think, is pull in what mu is so that we're really clear on that too. So mu1 is it's going to be the same parameter, but in each from a different group, right? So we're going to get this one. And actually, let me just go ahead and get both of them. Let's see what Excel does with that mu. May not be able to handle it. Yeah, I didn't think it would. All right, that's fine. Let's get rid of that. So now that we know we need the average square footage from each group, I'm going to go ahead and get those statistics. So the first thing I'm going to do here is I'm going to say this is from group 1. And I'm going to go to the data, and I'm going to go to data analysis, and I'm going to go to descriptive statistics because I'm going to need the sample variance and I'm going to need the sample mean. So I'll say, okay, my input range is going to be over here in group 1, and I need the square footage of the home. So I'm going to select the square footage. I'm going to have a label in the first row. I'm going to select the output range. It's going to be right here. And I'm going to pick summary statistics. So I pick OK. So now it's going to calculate those for me, I think. There we go. And it looks like I need to make this column a little wider so I can see what we got. Okay, so now I have this right here, right, is my X bar. And this down here is my S squared. S squared. So let me just go like this. Whoops. Squared. Right, my sample variance. Let me pull up the analysis plan right next to it. Maybe we can just put that right over here so we can kind of follow along. All right. So I'm looking at this S1 squared and S2 squared. I got my count, so this is my N1 down here. So yeah, so this is my N here, right? So this is for group 1. So that's X bar 1. I got X bar 1 from this formula. I got the S1 squared and I got the N1 down here. I'm just calling it N because I'm going to now over here put the same thing for group 2 so you can actually read across. So group 2, and here I'm going to do the same thing from group 2. So I'm going to get the square footage in my group 2. So again, data analysis, descriptive statistics, and pull that out. I'm going to go now to group 2, and I'm going to pick the square footage there. And I'll say, okay, good to go. Need to pick where I want it. I don't want it in B10. I want it in F10. Everything else is good. All right, that's going to calculate that for me. And once again, let's make that bigger. So now we're going to have this part done. So let me shrink up my Excel so we can refer again to the test statistic. So really what we're going to do now is just go ahead and calculate the test statistic, pulling these values in. So let's start out with the numerator. And I'll make this first column just a little bit bigger. Okay, there we go. And so the numerator is going to equal the difference in the means. So it's this cell minus this cell. So that's the difference in our means. And it is subtracting mu1 minus mu2. Now, remember, I did the little math where we subtract mu1 from mu2. We're going to assume the equality that comes from H naught. From the null hypothesis, so we get that mu1 minus mu2 is 0. So the expected difference in the means is 0. And we want to see if it's actually greater than. And that's sort of the upper bound of, that's the upper bound of the null. So that's the, it could be less than, but we're going to use the upper bound of the null to set that. So we have 0 here. And then we need to get this denominator. So this denominator is a little bit more complicated. So let's go ahead and build that. So denominator. So it's equal to the square root. And here we're going to have the sample variance. So that's S1 squared, and we're going to divide that by the number of observations, the sample size in the first group. And then we're going to add to that the sample variance from the second group, and we're going to divide that by the sample size of the second group. So putting that all together, I now have my denominator. So now I'm going to get my test statistic. And it's just equal to the ratio. So it's the numerator divided by the denominator. Okay. So now that I have my test statistic, I'm going to, if you remember, we need to now test this by looking at the probability. So what we're actually looking for to test our hypothesis is because this is going over here, this is a right tail test. We want to see if mu1 is greater than mu2. So we want to know, and also the test statistic is a positive number, is the other way to know it's a right tail test. So what we're really trying to determine here is the probability that some standard normal z is going to be greater than or equal to this number. So I guess we can just type it. Whatever it is, and that is equal to 1 minus, right? Because if it's going to be greater than, and Excel can't do that, we're going to have to do 1 minus the probability that the standard normal is less than or equal to. And you might be wondering, why is it okay to have an equal to? And that's kind of a statistics theory thing, that at any single point, there's no probability. Don't worry about it. It's just okay if you to do that. Okay, so this is what we want to determine now. And what I'm going to do is go ahead and get that here. So now I want to calculate this. So we're going to put 1 minus, we're going to follow this. And remember, it was the norm.s distribution. And we have to put the z right here. It tells you what to put. It wants the z. So we're going to put the test statistic, which is the z, and then cumulative. We want true, so that we do get the probability distribution up until that point. So putting that in, we get 0, and you're like, 0. So let's go back to the home screen and add more decimals. So we're looking pretty tight here. Like this is a really, really close to 0 thing. All right. And obviously, if you remember standard normals, they have a 0 mean and 1 standard deviation, standard deviation of 1. So we're at 26.57 standard deviations from the mean. So yeah, we're really close to 0. So then you want to make your decision. So your decision, remember, would be is equals to if the p-value, so this is the p-value. I should have probably wrote that. I'll write it in a second. So if that p-value is less than the alpha, oh, we need to write the alpha too. Okay, let's stop this and make sure we put all that in here. All right, so first of all, let's call this the p-value. All right. And let's go up here and state the alpha at the beginning. So we'll state here alpha, and it's 5%, so 3%, 0.03. All right. Now, if you want, you can write that as you can format it as a %. Maybe format this right, justified. Okay. Center that, I don't know. Okay. You can play with the formatting, make it look nicer if you want. Okay, so now this is the p-value. So my decision, let's do that again now. Now we have it set up. So this is going to equal if the p-value is less than alpha. So this is our p-value, is less than our alpha. Notice that I'm not typing, trying not to type any actual numbers. I'm letting Excel do all the calculations for me. Many reasons for that. One, I want you to get into the habit of trying to plan ahead in case you have to redo this with new data. And also, so you're really clear that you want Excel to do the work for you. Okay, so what do we know if the p-value is less than alpha? Well, then in that case, we're going to reject the null. And if the p-value is not less than alpha, then we do not reject the null. So now our decision is being done for us without us having to think, really. I mean, we had to program it, but now we have that decision for that first hypothesis. Okay, so for the technical report, I am going to use this information and write a sentence. I'm gonna share what I found, and I'm going to state what the p-value is. I might be able to get this in scientific notation. Let me see if I can do that. Yeah, scientific. Wow, it's really small. That is so small. Okay, well, this makes me suspicious. Something isn't quite right, but it looks right. Okay, shouldn't be 0, 0, 0, but I'll double check that. But I think that that's a really, I think that's so small. The probability at that tail is so tiny that it's going to be beyond the capacity of Excel to express it, is I think what's going on. So it's really small. Okay. Anyway, I'm going to use the p-value. I'm going to state the alpha, and I'm going to state, of course, I'm going to give the point estimates for the means. I'm going to give the sample standard, sample variances. And of course, I'm going to have already stated the sample sizes, and then I'm going to state the decision, and then I'm going to write it as a sentence and explain what the result of this means. So because I'm rejecting the null, I am going to accept the alternative. So I'm going to basically make a statement that says that that at a 3% significance level, the data indicates that that on average, the square footage in houses with 3 bedrooms is greater than in houses that have less than 3 bedrooms. So nothing so surprising or earth-shattering there, but depending on what your hypothesis is, it could be important. So again, this is just to get you guys used to the idea of how you do this. Okay. So now the next part of my hypothesis is extra credit part. So I think for that, I'm going to not do a video because that's extra credit, and I can tell you that you need to have it all in Excel so you can build all the pieces that you need and then put in and create the confidence interval. And I did a Excel video on how to do that at one point. Okay, now let's move on to the second one. The second one says at a significance level of 20%. So let's go ahead and before we do that, let's get to where we are. And let's rename this worksheet hypothesis test 1. Okay, and I'm going to add another worksheet here, and I'm going to call it hypothesis test 2. Okay, now, whatever your grouping is, so my hypothesis test 2 is the same. My groups are the same, and I know you're not allowed to have that, but I am. So I did that. And I am going to take and copy this part down. Oh, nope, I'm not. I'm only going to copy this part down and I'm going to change a bunch of it anyway. So let's copy this, Control V. And here I'm going to apologize for my dog barking. I'm going to copy this over here and copy the question over. Okay, there we go. Okay. This is so wide. You may not want something so wide. What you could do is just kind of pick how wide you want it and hit this merge and center button and then hit wrap text and right justify it if you want. So kind of squeeze it in a little bit better. Okay, the alpha for my second hypothesis is 20%. So I'm going to change this to 0.2. Really? What's going on? Oh, it wants to put it as a percent. Okay, 20. Gotcha. All right. My group 1 and my group 2 is the same, so I'm not going to make new subsets. Now I'm going to come in and I'm going to have the proportion of houses with 3 or more bathrooms and the proportion of houses with more than 3 bathrooms in each group. So we're going to get the same thing from each group. So let's go ahead and figure that out. So we'll put that in here so we don't mess ourselves up. We're really clear that we want what we want. All right, so for group 1, we're going to need the X. So X is going to equal to, let me just come up here and define that. Now add another, maybe I'll insert another row here so it's not so squished. So I'm going to say let X equal the number of houses with more than 3 bathrooms. Okay. And I'm going to do that for group 1 and group 2. Okay, so let's now also format this. So it's the same. All right, so what we're going to do is we're going to basically get a little bit of information here, and that will enable us to get our sample proportions. So we need the P1 and the P2 is basically what we're trying to go for. We could actually write that here. So we could say sample proportion. Okay, sample proportion. All right, so I'm going to go to group 1 and then I'm going to repeat what I'm going to do in group 2. And so for group 1 and group 2, what we're going to want to do here is create another pivot table. So we're going to create a pivot table for group 1. So let's go over here to group 1 and we have all this data. So in here, I want to consider the count, right, of records where they're coming from houses that have more than 3 bedrooms. So my group 1, remember, is my houses with 3 bedrooms. So here I am in the houses with 3 bedrooms. And I'm just going to do a pivot table just on baths because that's the count I want. So I'm going to go to insert pivot table and I'm going to put it right here so I can get it right here. I'll say, okay. And I'm putting baths down in rows and I'm going to put the count of baths down in rows. And I don't want the sum. So I got to change that to count. Okay. So I want the count. And then here I can, so this is the count of baths and this here is the number of baths. Number of baths. And so just to be clear, if a house has 1 bathroom, there's 813 records that have just 1 bathroom, okay? So I wanna know the ones that have greater than 3. So I'm gonna go here to the value filter sorry, no, the label filter. And I want it to be greater than 3. Because I don't want to filter on these actual counts. I want to filter over here on the labels. So I want that to be greater than 3. And I see that my grand total is 167. So I'm going to come over here to hypothesis 2, because in case I change something, I don't want to just type in that number. I'm going to point this to the location of that answer. So I'm going to go point group 1 to this 167. Okay, so I have 167. So we also are going to need the number, the sample size. And remember, the sample size is one of the things we put into the analysis plan. And we had those numbers already calculated. So we can actually go back and get those again. It would have been nice to have done them ahead of time and put them here. So actually, let me sure we're in the right place here. So we need N1 and N2 here as well. So we might as well go ahead and do it. So going back to our hypothesis prep, oh, this was all set up from when we set it up for the count of beds for that were bedrooms, houses with less than 3 bedrooms. So let's go ahead and copy that over. So let's go over to our hypothesis 2, and we're going to put that under group 2 for the sample size. All right. And then we need to go back and get the amount, our sample size for group 1. Okay, so going back to that, hypothesis prep pivot table for me. Again, you could use count ifs too for this. I'm going to go in and I'm going to choose 3-bedroom houses, and I have a quantity of 5182. So let me go to my hypothesis and point to this value. So this will point to this number. And yeah, okay. Okay. I don't know why that's formatting like that. Okay. So the next thing we need to do is do the same thing to get the counts. We're going to get the same count for group 2. So I'm going to come here to group 2. And once again, I'm going to get the number of baths. I'm going to create a pivot table for the number of baths. So real quick, this is just a repeat of what I did for group 1. We're going to do the exact same thing in group 2 that we did in group 1. We're going to get the number of baths, and we're going to get the number of, we don't want the sum of baths, we want the count of records that, we want the count of records where the number of bathrooms is as it is. And then we want to know the ones that have the proportion that are more than 3. So again, I don't want the counts where they're more than 3. I want to know the houses where there's more than 3 bedrooms. And those are the actual labels for our different categories here. So we're going to go to label filter as greater than 3. Okay. And so we see that for houses with less than 3 bedrooms, there is a grand total of 7. So that's the number that we're going to want to use for our X. It's the number of houses with more than 3 bathrooms in group 2. Remember, group 2 are houses with less than 3 bedrooms. Okay, so we can scroll down here. You can double check. Okay, so we're good there. So let's go back to our hypothesis 2 and point to that number. I'm going to equal group 2, and let's point to that number. We got it. Okay. So now that we've gotten our X and our N, we're going to get the proportion that each one is. So equals X divided by N. So that's the proportion of houses with more than 3 bathrooms in group 1. And we can just copy this formula over for group 2. So here are our proportions, and you can leave them as decimals. You can also format them as fractions. You definitely would want to report them as fractions, but we're going to need some more decimals here, I think. Let's just go out a few decimals. Okay. So now we are going to compare these proportions by doing our our two group. So we want to check that the normality conditions are met. So let's go in and check our normality condition. So N1 times P1. And let's just call this N times P, and we'll just do it across the row, and we'll have it part of the table. So we'll stick it up here. All right. You can worry about formatting later. But this one's going to be equal to the sample proportion, sorry, the N was followed times the P. So N times P. And we're going to repeat that here. Ooh, this one barely is, right? So, but we made it. They're both greater than 5. So we can write a little note here. And we can say normality conditions have been met. And so therefore, can use standard normal distribution. Now you can play around with formatting that if you want. It's hard not to. Okay. So over here in our analysis plan, hopefully you knew to write the standard normal distribution. Weird formatting thing happening. Okay, and now the test statistic that we're gonna pull in here is that really weird one. So let me just go ahead and delete this, and I'm going to copy it from my notes. I think there was a table or chart that maybe you could get it from. So I have this, and I can say where we have this little PP thing going on. All right, so we have these two formulas, and these are the formulas that we're going to use to create our test statistics. So we need to first come up with this little PP function that then gets inserted into the overall calculation for the test statistic. Okay, so let's first of all look at that. So we're going to say PP numerator. So this is going to equal the P1 times N1. So we kind of did that already, right? That's P1 times N1. And we're going to add to that P2 times N2. Okay, so we're putting those together. And then we have the PP denominator. And so for that, we're going to get just N1 plus N2. So that's just going to equal N1 plus N2. Oops. And that's up here, isn't it? Got to fix that one. Grab the wrong one. Okay, let me grab it. Come on. Right. All right. So we have our PP denominator. And so now we can get our PP. And that's just equal to the numerator divided by the denominator. All righty. Now that's part of the whole denominator or the standard error. So we can actually calculate the standard error And that standard error is given by the square root of this PP times 1 minus this. It's pooled proportion is why it's called PP. It's a pooled proportion. And that's times 1 divided by N1 plus 1 divided by N2. Okay, and then we close the square root and we have this number. So that's our standard error, 0.005. Okay, now that we have that, we can get our Z, our test stat numerator. So our test stat numerator is going to equal the difference in proportions. So it's going to be this number minus this number. Okay, and our test stat denominator is going to equal, well, we already have it. It's the standard error. So let's eliminate that. Okay, so now we're going to get our test statistic. And it's going to equal the numerator divided by the standard error. So the difference in proportions divided by the standard error. And we get that it's 5.055. Okay, so now I just want to make sure I have my formatting about the same. All right, so now that I'm going to do a p-value to decide what we're going to do on this one. So let's get the p-value. And this is a right tail test, so it's the probability that some standard normal random variable is going to be greater than or equal to this number right here, 5.056. Let's just round because this is just to guide the reader. And again, Excel can't handle right-tailed probabilities. So it only wants to do cumulative from the left. So we have to subtract, we have to do 1 minus the probability that Z is less than or equal to 5.055. 056, whatever it is. I'm not actually using those numbers. This is, again, just to guide the reader. I want to make sure I didn't make a mess up on the type. No, I got it. Okay. All right. So we're going to say equals 1 minus. And to get the left tail probability, we're going to, from a standard normal, we're going to norm dot S dot distribution. And we're going to point to that test statistic, which is follows a standard normal distribution, and we're going to say cumulative is true. And now we have a p-value, and we're going to use that same, I can copy this decision information over. And just copy that, see how much of it translates. I think their alpha might be in a different place, but we'll see. Yeah, so let's find out what happened to the alpha. Alpha, where'd you go? So if the p-value is less than the alpha, oops, let me get up here. Let me delete this part right here. So if it's less than the alpha, which was 20%, we were willing to go to 20%, then we're going to reject the null. So both of my hypothesis tests turned out to be significant. That may not be the case with you, and you may end up with do not reject the null. So depending on what the results of your hypothesis tests are, you would, when you do the technical report part of this, you would write about that. Okay. And I did many examples in class where I converted the results into English. And I was saying, you always want to write your answer. You want to give a summary in English. Okay. So with that, I think this Excel demo is complete.